Hi, thanks for being here. My name is Stefano Tempesta, and in this video I want to show you how you can digitally sign and verify documents on a blockchain. And I'll do this together with two friends of mine. So please meet Laura. Laura is a student, 23 years old, from the Netherlands. She wants to travel to Australia and work there, but she's going through all the complexity of immigration, getting a work visa. She has to prove that she has a degree, knowledge of English, and a lot of paperwork. This process is taking days, weeks, even months. It's very cumbersome and is wasting everybody's time. Now, meet my second friend of mine. Please meet Robert. Robert is a doctor. He's Australian and is looking after a lot of patients. But every other year he has to go through a requalification, attend some training courses, and prove to the authority for practitioners that he is still qualified. Again, a lot of paperwork to produce, and documents, and waste of time on all the parties. He wants to focus on his job, on his patients. Is there a way to do all this better, in a more efficient way, more quickly? Well, it's clear that Laura and Robert have a common challenge. They have to prove that their qualification, their certificates exist, that they are authentic, that they've not been forged, and they have to prove it with the relevant authorities. So in a way that there is an evidence that is verifiable by all parties. This is the process of digitally signed documents. But what can blockchain add to the existing established processes of digital signature in the industry? With blockchain, you can imagine a world in which documents are embedded in digital code and stored in a transparent, shared database where they are protected from deletion, tampering, and revision. So in this world, every agreement, every process, every task, and every payment will have a digital record and a signature that could be identified, validated, stored, and shared. So intermediaries like lawyers, brokers, and institution may have a different role, may not be longer necessary. Individual, organization, even machine will freely transact and interact with one another with little friction. Quickly, in minutes. This is the immense potential of blockchain. The potential application of content decentralization and distribution is enormous. People will own their own digital identity and their record. Think of identity of residence documents, medical records, educational, professional certificate, licenses. Then they will create a single, immutable, and verifiable record store. All these documents and their metadata, as we will see soon, can be issued on the blockchain and be digitally signed. No more fake certification, no more degree mills, no more Photoshop papers. Students, for example, may apply for further study, a job, immigration to another country. They may require to prove the level of study or knowledge of language to attend a university. Entities like recruiters, employers, government, universities, they can verify the student credentials without relying on central authorities in just minutes, and with no other intermediaries. Still not convinced? So why blockchain to sign and verify digital asset when solutions for electronic signature already exist and are broadly adopted in the industry? So without the need for a central certificate authority or central timestamp server, which are the typical dependency of existing e-signature systems, digital signature stored on a blockchain live independently of the object being signed. This opens the opportunity for parallel signing, independent verification, with or without the object, the document itself. Traditional e-signing solution store the digital signature inside the document. This means that whoever needs to check if a document is signed will have full read access to all the content in the document. Also, because the document changes with each signature, signing documents in parallel is not possible. Everybody needs to sign the document sequentially. And by signing documents on a blockchain, the object is not changed by the signature, which also enables you to sign documents in parallel and implement business rules based on mandates, for rights, majority of vote, seniority, etc. Each registration is linked to a specific case, document and task performed by the parties involved, creating a chain of transactions, an auditable trail. This audit trail can then be verified by authorized third parties, providing transparency, compliance, and most important, trust. This is the website of a fictional malware university. I want to sign a certificate. It's very important to understand that the file themselves is not stored on a blockchain. So I'm going to upload now a file, and I have a PDF with my diploma. Let me show you that before. This is my diploma of Power Rangers, issued on the 13th of November, year 2000, all signed by the principal and the superintendent. Alright then, so let me upload this file. This is now going into SharePoint, in this case, hashed, and a signature, a unique hash register in the digital ledger. Let's have a look at the process for signing documents on a blockchain. Certificates are issued by an authority, say an education institute, stored on a centralized document management server or a distributed file system like IPFS, the interplanetary file system, and signed with a cryptographic function. The document URI and content hash, so the certificate metadata, are then encrypted and stored on the blockchain digital ledger and attached to the user digital identity. The system issues a unique authenticity token which identifies the document in a non-questionable way. A common pattern is to generate a unique hash of the digital asset and the metadata that describes it. Those hashes are then stored on a blockchain. If authenticity of a document is ever questioned, the off-chain file can be rehashed at a later time and that hash compared to the on-chain value. If the hash value match, the document is authentic. But if just a character in a document is modified, the hash values will not match, making obvious that a change has occurred. And now, the verification process. So, remember my Power Ranger certificate? I'm going to counterfeit it, make a fake one, because there is a requirement for immigration, for example, to be a superhero. So here we go, I'm gonna save my file, and from now on, I'm no longer a Power Ranger, I am a superhero, so I can falsely meet the requirement for immigration to Australia, say. So now that I'm a superhero, I'm ready to share this document. But what happens during the verification process is that a hash value is being calculated again for content and metadata, compare with the existing one that is stored on the immutable digital ledger, and obviously the values don't match, so the files are not the same. Even if they are stored in the same location, with the same file name, with the same attribute, they are not the same. Users who need to have their certificates verified by a third party share the authenticity token, that is the file contract address, which contains all the necessary information to verify that the document exists in an authentic format, not counterfeited. Processing documents, but also any unstructured data and their metadata, integrates these with blockchain to create an immutable and independent verifiable record of transaction. This is proof of existence and authenticity of this digital asset. So, in summary, proof of existence refers to creating an unalterable date and timestamp for a specific object, a document. This means that you can prove that a certain information object, like an email, a document, an image, existed at a certain point in time. Proof of authenticity asserts that an object is authentic, that is, has not been changed since it was stored at the indicated time instant. This is accomplished by digitally signing an object, as we have seen before, and thus creating a hash, its unique identifier. The identifier gets then committed into the distributed blockchain ledger, and the transaction gets timestamped as well. Since every entry in the blockchain is immutable, this means that you have proof that this specific object existed at a certain point in time. The Azure Blockchain Workbench tool has capability for integrating with external systems. The Azure Blockchain Workbench REST API sends authenticated requests to execute transactions on a distributed ledger. The external application, in this case, can be your SharePoint or your OneDrive where the document is stored, authenticate into an Azure Active Directory, which is provisioned as part of the Azure Blockchain Workbench deployment. The authorized users receive a bearer token that can be sent with a request to the API. The external application makes a call to the REST API using this authentication token, and this API packages the request as a message that sends to the service bus. From here, it is retrieved, signed, and sent to the appropriate distributed ledger. The blockchain integration flow, which I have implemented with an Azure Logic app, basically looks for a file being uploaded, created in a folder, in this case in SharePoint, but again you can use any document storage. Then a hash of this file is calculated, taking the content in input using an Azure function, and the metadata is hashed as well. In this case, I'm using a few elements of the document in SharePoint that identifies the document in a unique way. I then initialize the request, and in some input variables, a unique request ID, I simply generate with a GUID, the current process date and time, the identifier of the user on the blockchain workbench, and the address, the blockchain address of the smart contract that I'm consuming. Packaging all together into a message in the JSON format and sending this to the service bus associated with the Azure Blockchain Workbench. So, in summary, what are the technologies that I have used for digitally signing and verifying documents? Your document storage, I have shown you a SharePoint site, it can be OneDrive, it can be IPFS. It doesn't really matter because the document itself is not stored on a blockchain. So your storage is independent from the blockchain platform. But the integration happens through the Azure integration platform. I have used Logic apps and a connection to the Azure Service Bus. At the foundation, we have Blockchain Workbench as the platform for exposing an API for communication with external application, and obviously the blockchain digital ledger itself. We are at the end. Thanks for watching this video. Please get in touch if you have any follow-up question. You can see my social coordinates, my blog on screen now. Thank you. Ciao.